The goal today is to evaluate determinants. The definition of a determinant is that it helps determine if a matrix has an inverse. Helps determine if a matrix has an inverse. The first requirement is that the matrix must be square. And the two sizes we will work with are 2 by 2 or 3 by 3. We will not do any bigger. Number 2, the determinant is the difference or subtraction problem, difference of the products of the diagonals. So a determinant can be found by multiplying the diagonals and taking the difference. You do have to do that in a specific order. So let's start with example 1A. I'm first going to give you the generic matrix A, B, C, D. What size is that? Good, perfect, 2 by 2. And first diagonal, we're going to go down and multiply, would give us AD. Now remember, the word difference is a minus. Then we will do the diagonals going up and to the right, and that would be CB. The answer would be the determinant. Yes, Isaac.
I was just wondering, is it okay if I do BC? Because isn't that same?
Order of multiplication does not matter. I would prefer you go by the formula that I gave you. But he is right. If he did BC or CB, why is that perfectly correct either way? Not associative. Somebody know? Right. Order. Commutative. Good.
I just list them until I get it right.
Let's try a real one with numbers. Let's use matrix 5, 4, 3, 1. Remember the diagonal down first gives us 5 times 1 minus the diagonal going up and to the right will give us 3 times 4. Five minus 12 is -7. So before we do anything with determinants, we have to figure out how to find determinants, and then we will begin using them. I'd like for you to try one on your own. I want you to talk to your elbow partner and see if you can both come to the same solution. 3, -2, 6, 1. Yes, Perla? Doesn't matter. You're talking about the matrix brackets? Yeah. Once you're done, ask the person beside you if they got the same AD minus CB as you did, and if they got the same answer. Two people nodding their head. Anybody else check? Amber, you check with Vincent here. Are you all not ready to check, or did you already check with? Okay, so you're good. All right. How about back there? Everybody checked? Derek, tell me what you got. No, I mean the steps. Okay, I couldn't hear the beginning, but I think you said 3 times 1 minus. I heard the 6 times negative 2 is right. And so what is 3 minus negative 12? Thank you all. That's so gross. I'm sorry. All right, so 15. And did a bunch of people get that right? Good, good. So we can find determinants of 2 by 2s. Do we feel good about that? Good. All right. Now let's try a 3 by 3. Remember, the process is the same. It's just a little bit longer because the matrix is larger. Now, I want to ask you a quick question about what you think. If I'm supposed to go down and to the right first, I'm good with this first diagonal, right? But what happens when I try to do this guy's diagonal? What's missing right here? It really needs what? This over here. And what about when I try to do this guy and there's only one? There's a trick. Do you guys know what it is? Sometimes on academic teams, so that you guys can do these in your head, they teach you to rewrite the first column and the second column so that you're not wrapping around, because wrapping around will often cause arithmetic mistakes. What is this step for? So that we have enough what? Numbers to do diagonals. That's all that extra step is for. You rewrite column 1 and column 2. It starts the same, and you multiply 2 times 1 times negative 2, and that's negative 4. Your next diagonal is nice because it has a 0. Why is that nice? 0 times anything is what? 0. And then your third diagonal is negative 12 times 4 is positive 48. So that is my down and to the right diagonals. I'm multiplying the diagonals, and then I'm going to sum all those up in just a minute. It's still a difference problem. And so what am I going to do now? If I've gone down and to the right, what is the next step? I want to make sure everybody's got that copied down. It will be confusing too, Danielle, for the first like 5 times you do it, and then it'll just become secondhand, just like multiplying in a please excuse my dear Aunt Sally problem. So just be patient with yourself, because it is confusing at first. After I do the down and to the right, what do I do next? Go what direction? Up and to the right. So 3 times 1 times negative 3, do you agree, is negative 9? And then we have the nice 0 again. Why is he nice? Because he gets rid of everything. And then negative 2 times 4 is negative 8 times negative 1 is 8. Now, because of order operations, Nathan, how do I attack this problem? Help me.
Well, you add all the stuff in the parentheses together first.
Good, perfect. So I have 44 minus, what do I have over here?
B, -1.
Okay. And so what's going to happen when I do the negative of a negative 1? Right, perfect. So what's my determinant of this guy?
40.
Why was he harder? There was more to the problem. You had to add 2 extra columns, and you had 3 diagonals to add and then take away the 3 diagonals going up after they were summed. So I want you to try and see if you can get the answer on one that you and your elbow partner are going to work with. I called this 2A, so I'm going to call the next one 2B. Does anybody need more time on 2A before I give you 2B? Anybody? Everybody ready? All right, 2B. The straighter you write your columns, also the easier these problems are to do. So is it square matrix? Are we even able to find a determinant of it? What do y'all think? Yes, good. It is a 3 by 3. It is a square matrix. What is the first step that you're going to do, Nikki, to start? Good, because we're going to use them as helping us with the diagonals. See if you and your partner are getting the diagonals right. I missed the first one, had to redo it. Did anybody get the same answers I did? Oh, that's so close. Which part was off? Look at your little numbers in here. Were those okay?
I forgot about the 0.
-8, 0, and -30 is what I got first. Did you get all those? The 1 should have been not there. Why? Because -1 times -1 is 1, but then what did you forget to multiply by? That little 0. Anybody else miss it by 1? Oh, you got one? Uh-oh, look at my green and my pink and see what you did that didn't match, and then we can figure out which diagonal you messed up. Who got it right? Let me see hands of right people. A few people, good. How many times have you done a 3 by 3? Twice now. Once with me and once by yourself. Did you see it, Sammy?
I forgot the 0 times something or 0.
Oh, so did Caleb.
That little part.
Yeah.
I'm good at algebra, not math.
Any luck, Sammy? All right, while Sammy's doing that, I'm going to show you one real-life use of the 3 by 3 determinant.
Yeah, sound like I think of 20.
If I write it like that, this is example 3. If I write it like that, there will be no directions. What do those straight matrices mean? See, it's hard, isn't it, when we use the same symbol for something different. What these say without any words is you're going to find the determinant. Isn't that nice? I did. But why did I want you to mess up right then?
Because you hate us.
No, because I don't want you to mess up later. If I gave you an island and told you had to find the area of it, you could use matrices. You guys want an island?
I'd like an island. No, we don't.
Well, you don't. I didn't say you had to be trapped. I just said I was going to give you one.
Can we get a boat too?
Own it. We have to pay taxes. How would we sell it off?
This island I'm going to give you is triangular shaped. And the formula is that you're going to take half of the determinant. The determinant of what? 0.1 with a placeholder at 1. 0.2 fills in with a placeholder 1. And 0.3 fills in with a placeholder 1. So if I was giving you an island and it depended on you being able to do a 3 by 3 determinant and multiplying it by 1/2,
I'll be 9.
could you do it is the question. Couple people want to try at least. Right? Wouldn't we want to at least try? That is so true. All right, so my first point off of the coast of California, I believe was where the island was, is -141. Well, yes. I stole it out of a book. 0, 0. And the last point is 38, -43. So it would be significantly this way. So does this make a triangle? Which one do you need?
The last one.
Oh, the last one is 38, 43. Or -43, sorry. So it's a decent sized island, and we want to know the square footage of it. So first of all, using this brand new formula that you've never seen ever before in your life, how would you fill it in? What does x sub 1, y sub 1 mean? Right, perfect, the point. So my first point is at, and I always start as high as possible and I go clockwise. So my highest point on a coordinate plane is -1, 41, and then I need my placeholder 1. And if I'm going clockwise, what would point 2 be? Be careful here because I have the little negative above it. x2, y2 would be 38, -43. Then your placeholder 1. Now why is everybody going to love point 3? What does 0 make the diagonals turn into? Nice little zeros. Now what do we have to add down here at the end? Because it's a 3 by 3, -1, 38, 0, 41, -43, and 0. What is it? I'm not there yet. And that's not the answer I got. Oh, yes, it was. Yep. I was starting to say that's not it. Now you got to cut it in half. Multiply it by positive and negative, and then only keep the positive area. Now, what do we do first? We're going to take our diagonal. And what do I get from that diagonal? 43. What is very nice about the next two diagonals? They have 0. So what do we say? 0 plus 0. Do you agree with me that it's 43 plus 0 plus 0? Okay, good. What's nice about the first two going up into the right diagonals? They're also 0, but now I have to do 1 times 38 times 41, which I got 1558. Did anybody else get that?
Yeah.
Okay. So I have 43 minus 1558. Now what have I not done yet? What's sitting out here waiting? Yeah, plus or minus a half. So this, I got -1515. Did anybody get that? Good. So one of my areas of my island is -757.5 square feet, and one of them is 757.5 square feet. Which one of those is the real area? Why did we throw out the negative? We cannot have negative area. Very good. Now, that is not especially hard, but it does take precision. So we are not going to practice the area problems tonight. We are just going to practice the determinants tonight. So what are we going to do with those? We are going to move towards